Hello everyone and welcome back. In our last lesson, we came up with our test cases. In this lesson, we have to come up with a solution without any code, which is a logical solution. But the nature of our question is going to be a little different from what we're used to in the last array question that we solved. Let's just quickly go over it because it's going to be important. In the last question that we solved, our question asked us, given an array of integers, and return the indices of the two numbers that add up to a given target. I'm certain everyone remembers this question. As we remember, the question simply asked us for a solution the moment we found one. This means that if we were given a target of 4, and then we were given this array, if we were to find our answer using our brute force solution, let's just take our logical solution. We pick the 1, and then immediately we pick the next number, 3. We see that 1 and 3 added together give us 4, and automatically we found our solution. We just take the indices here, which is the 0 and 1, and we return our answer. Our code is done, our solution is found. This question did not require us, after we found the 1 and the 3, to check any other possible combination of numbers, because our question was simply asking us to return the indices of two numbers that added to a given target. The moment we found our target, we didn't care anymore. Our current question, on the other hand, is giving us a very similar array of positive integers, but here we need to find two values, which represent two lines, that form a container that would hold the greatest amount of water. And then we return that greatest amount. So here I want to focus on this word greatest. This is a maximal value question, which means that we're looking for an answer that is the greatest amongst all of the possible answers that we can come up with. Unlike our previous question, which was where the moment we found an answer, we were done. We could return that we had two values that added to a target. Here, it's different. We find two values that form a container. That does not mean that it is the best possible container. The best container can only be determined if we have every single container first. So that's a very key thing to remember about this type of question, where we're looking for some specific max value. There's a chance that we might get a question that wants us to find a minimum value, which, if you can imagine, we had a same question, but instead of the greatest amount of water, we were looking for the least amount of water that a container could make. Either way, the only way that we know we have the greatest or the least amount of water held by a container is if we calculated every single other container first. And then from amongst all the possible solutions, we pick the one that was the smallest, or we pick the one that was the greatest in the case of this question specifically. So this is a very important thing to remember when it comes to coming up with our logical solution. And this is a very common type of question. Just like our previous question, there's a difference in how we approach the solution, because we have to remember what we're looking for changes how we even solve it in the first place. So this is one thing we need to keep in mind. So let's take our first test case that we came up in our previous lesson and use it to come up with our logical solution. We know we need to calculate every single container, but with this test case, at the very least, we know that the correct answer is created using the 7 and the 9. So let's go over what we need in order to come up with max area. So max area is calculated using length times width. The length, as we remember, is the lesser of the two values we've selected. So let's say that we're using A and B as the variables that hold A being the left, B being the right value. So left, as we remember, is the minimum between A and B, because it's the lesser of the two. Width, as we remember, is the index of our rightmost value, so B, and we can represent it as BI, minus the index of our leftmost value, which is A. So here it's AI. This is going to be our general formula for area, and as we spoke about this question, we need to use this formula with every possible combination of pairs of elements. So let's just do what we did in our previous array question, where we had 2 pointers. The first pointer, which we'll designate A because that's really what it will be anyways. Actually, let's use a different color just to be more clear. A is our first pointer. B is our second pointer. And B is our value that moves along and checks. And as we remember, this works because B also happens to be the rightmost value. So now that we know what we're doing with A and B, we are just going to calculate max area for these two numbers that we've selected. So let's also keep track of max area. So here max area initializes at 0 because max area, when nothing's calculated, we can't return null. We just say max area, which has to be a number, and the smallest number is 0. Now we run our formula against the two elements we've selected. So we get the min value between 7 and 1, and then we multiply this by b of I, which here we can see b index is 1, minus the a index, which is 0. So minimum between 7 and 1 is 1, and 1 minus 0 is also 1. So this means that our max area, 1 times 1, is 1. Now we compare our current max area of 0 against 1. Which one's greater? Our new one is greater, so we replace the current max area with our new max area. And then we move B forward. So let me just erase all of this. And now we need to recalculate. We need now the minimum value between 7 and 2. And then we multiply against the B index, which is 2, minus the A index, which is 0. The minimum between 7 and 2 is 2. 2 minus 0 is 2. 2 times 2 is 4. Once again, we compare. Is our current max area of 1 greater or our new area of 4 greater? Well, our new area of 4 is greater. So we're going to set our new max area to 4, and we're going to erase our calculation, and then we're going to move B forward to 3. Then we do it again. We get the minimum between 7 and 3. We multiply it by B of I, which is 3, minus A of I, which is 0. And this gives us the min of 7 and 3, which is 3. 3 minus 0, which is 3. 3 times 3 is 9. 9 compared to our old max area of 4 means that 9 is greater. So once again, we return a new max area of 9. We erase this, and we move B forward once again. Now we redo our calculation. We get the min value between 7 and 9, and we multiply it by B of I, which is 4, minus A of I, which is 0. The minimum of 7 and 9 is 7. 4 minus 0 is 4. 7 times 4 is 28. 28 compared to our current max area of 9 says 28 is larger. So once again, we update 28 as the new max area, and then we redo our calculation. Now at this point, we have to shift A forward, and we have to move B back to the first rightmost value of A. So in this case, it's 2. And then we do our calculation again. So here we're going to plug these numbers back in. We're going to get the minimum between 1 and 2. And we're going to multiply it by B index minus A index. So the minimum between 1 and 2 is 1. 2 minus 1 is 1. So 1 times 1 is 1. And we're going to compare it against our current max area. Is 28 greater or is 1 greater? 28 is greater, so no changes happen. B then gets shifted forward, and we erase our previous calculation, and we redo this calculation again. Is the minimum between 1 and 3 multiplied by 3 minus 1, since 3 is the index, and A index is also 1. So here, the minimum between 1 and 3 is 1. 3 minus 1 is 2. 2 times 1 is 2. Our max area of 28 is still greater than this new 2, so when nothing changes, B gets shifted once again. Now we do our new calculation. We get the minimum between 1 and 9 multiplied by B index of 4 minus A index of 1. Minimum between 1 and 9 is 1. 4 minus 1 is 3. Max area is 3. Our current area, 28, is still greater than 3, so nothing changes, and we reset our A and B because we've hit the end with B. A now gets initialized at 2, B initializes at 3, and then we restart our calculation. We get the min of 2 and 3, and we multiply this by B of I, which is 3, minus A of I, which is 2. The min of 2 and 3 is 2. 3 minus 2 is 1. This gives us a max area of 2. Compared to our 28, 2 is smaller, so our max area doesn't change. B will move forward, and we need a new calculation. Now, we redo our calculation. We get the min of 2 and 9, and we multiply this by 4 minus 2. The minimum of 2 and 9 is 2. 4 minus 2 is 2. Area is 4. Our max area of 28 is still greater, so once again, our max area doesn't change. And now we reset A and B again. A instantiates at 3. B instantiates at 4. We do our calculation. What's the min of 3 and 9 multiplied by B of I, which is 4, minus A of I, which is 3. Min of 3 and 9 is 3. 4 minus 3 is 1. Area of 3. Max area 28 is still greater. We've hit the end of our calculation. 28 remains. And there's no other cases left to test since we move A over. And there's no B that can be initialized. So we have our final answer of 28. So now we have our step-by-step logical solution. What I want you to do is actually try yourself first to see if you can turn this into a code solution. I'm going to show you in the next lesson, but this is a good chance to practice every single time. So give it a try and see what you come up with.